Hey, you know the way you're usually taught how airplanes fly? How there is a lower pressure on top and a higher pressure on bottom, which is caused by the fact that the air, when separated by the wing, has to reach the end of the wing at the same time? As it turns out, this explanation is kind of wrong. I say kind of because of the fact that I mentioned is actually not a fact and has been disproven for quite a long time now. However, the part with the higher and lower pressures is correct and is a source of lift, but isn't the main source of lift. If it was, planes would have to travel many times faster to take off than planes usually have to. This video will hopefully teach you what is the main source of lift and why it happens. To put it simply, the Coanda effect is the main source of lift. According to Wikipedia, this is the tendency of a fluid jet to stay attached to a convex surface. In English, this is just how a moving fluid likes to stay attached to a curved surface. I can easily demonstrate this by taking a glass jar and holding it such that it intersects a stream of water coming from my faucet. Water is a fluid, so it bends around the curved surface of this jar. And the same thing happens when I replace the water with air. So what's going on? I'm going to explain this using the air demo, since that's what's relevant for this video. When the stream of air passes over the top of the jar, friction between the air particles causes the air underneath this stream to be dragged along with it. This causes the stream to bend towards the jar due to the fact that there is now no air pushing on the bottom of the stream, and there is still air pushing on the top of the stream. In physicsy terms, this means a lower pressure has formed on the bottom, thus causing a net force downward. This causes the stream to bend and wrap around the jar. There are a couple of Newton's laws that are relevant for this topic that I must review you on to continue. Newton's first law basically states that if something isn't moving, it won't suddenly start moving without a force, and that if something is moving, it won't suddenly speed up or slow down or turn without a force. Newton's second law basically describes this mathematically. A force that an object experiences is equal to its mass times its acceleration. Newton's third law basically states that if something applies a force to something else, that something else applies the same force right back, but in the opposite direction. Alright, finally getting to airplanes. For the sake of explanation, we will only be considering an ideal situation with no initial movement in the air. As a plane moves through this ideal atmosphere, the air around its wing, which was originally motionless, attaches to the curved surface of the wing because of the Coanda effect. This accelerates the air downwards, and after the wing passes, the air is now left with the vertical velocity down. Because of Newton's first law, we know that since the air was originally motionless, the wing of the plane must have acted on the air with a force. And we know that since the wing acted on the air with a force, the air must have acted on the wing with the same amount of force, but in the opposite direction. Since the air was pushed downwards by the wing, the air must have pushed upwards on the wing, thus is our main source of lift. Now I might think that this little bit of air affected couldn't possibly lift an entire plane. I mean, planes are really heavy, but this Coanda effect affects massive amounts of air around the wing, as you can see in this clip I found. The amount of air affected is quite surprising, and as it turns out, is enough to lift the entire aircraft.